over the next few videos, we're going to look at subroutines and functions. We're going to see how we can generate functions, and we're going to see how we can pass values from these functions into subroutines, and how we can have these subroutines return values back to the calling function. Now, there's more involved in this than I can do in one video, and I want to keep the videos a little bit shorter. So that's what we're going to be aiming at over the next few videos. In this video, we're going to introduce another couple of directives which are useful along this route. So we know that we've got an assembler directive called origin 0x8000. We've met this one before. Now there's a new directive which I'm going to introduce, and it's the DC. So if we put in DC, now we have to put in the colon and then a space, and we can generate a variable. Okay, so I know it's called DC for define constant, but we can also define variables within it as well. So we can call this variable first, and we can put a value in this variable. So we'll put the value of 5. So what this does is it says set aside a memory location, call it first, and put the number 5 in it. So how do we know where the memory location is? Well, we have to tell it, and we tell it by using another directive, and the other directive is start address, and we'll put in, let's say, 0x8500. So this is an assembler directive which says go to a place in memory, and then for each subsequent position from that point, we can set aside memory locations which are going to hold variables, and it can also hold data. So this is a nice way of separating our code into the actual code block, and then somewhere else we're going to have the data and the variables. So this is our new value here, our defined constant. Okay, now we also want to define another constant, so we could say DC, and we could say second hash 3. So again, it just sets aside the memory location. So all it really does in this instance here is it goes to the address 8500 and it puts a 5 in it. It goes to address 3 and puts a 5 in it. So this is what the assembler does for us. Okay, so it does it automatically and we don't really see it. Okay, so we don't have to bother about it, and we've programmed it into the assembler to get it to do this for us. Now that we've got the two values, and let's say we want to add them together. Now we don't have the functionality to go, for example, add first comma second, because what we would be doing is we would be adding the contents of two memory locations. Now we could potentially generate a single command that did this for us, and the way the architecture is set out for our CPU, we have up to 16 different set enable cycles that we can use in order to generate really complicated instructions. So we could potentially generate an instruction like this, but I haven't gone ahead and done that because there's thousands of things I could have done. Okay, and in the end I had to have a simple, reasonably easy instruction set for us to work with, so this one isn't involved in it. Okay, so what we have to do in order to do the addition is we have to get the values into the registers first. Now to get a value into register, we know we're going from memory to register, so we have to use the load command. So we're going to load first, so that's the contents of the memory location 8500, and we'll load it into register R0. And then we're going to load second into register R1. So that's just going to take the number 5 and put it in register R0, and the number 3 and put it in register R1. Now we're in a position to add R0, R1, and we know it runs from source to destination. So the final destination of the answer is going to be register R1. So it's going to be 5 plus 3 is 8, and the 8 will be left in R1. Now let's say we want to save the answer somewhere in memory. Well, what we can do is we can use another directive. So we could set the directive ds. So ds stands for define storage. And this sets aside a memory location. Now let's say the value for it is answer. Okay, so we set aside a memory location answer, and we have to tell it how many bytes this memory location is. So in effect we can put in more than just one byte of memory location. We could put in multiple bytes. So we can put in the value in this instance. It's only just an answer, so it's just 1 byte. Okay, so it's 5 plus 3 is 8, so it just has to be big enough to store the number 8. So it's only going to be 1 byte, but potentially we could set up a structure here that has, say, 10 bytes if we wanted to. But we're going to stick with this here, define storage, and the answer is the length of it is 1. Now if we wanted to, we could go along here and we can now go from the register to memory. Now to go from register to memory, we use the store command. So we're going to store the contents of register R1 in the memory location answer, and then we're going to finish the code off with our end. So I think that's enough for our learning for this video. What we will do is we will take terminal run assemble, so we will assemble it, and it's actually come up with, if I zoom down here, it says assembly successful. Okay, so it has assembled it and everything's a-okay. Now what we want to do is take this, load it into our machine, run it, and make sure it actually works. So let's go and do that now. Let's load our program into the computer, and it's the directives, close, and I'll simulate this a little bit slower so we can see it actually doing something. So we should see our 5 in here, then our 3, and then it adds it together to give us an 8. And there you see we've got our value of 8, and it is now finished. Now the thing that we're interested in is where the answer is. So we said that the memory locations we set aside were the 8500 for the value of 5, 3 for 8501 for the value of 3, and then the answer goes on the next memory location. And that's the next memory location there, which is 8502, and it's got the answer 8. Okay, so that's a nice, neat little way for us to write our code, and it's a start along the track of producing functions and subroutines, and we'll get onto those over the next few videos. So thank you for listening. I'll get you on the next video. Goodbye.